All right, so now I want to talk about IP addresses and subnetting to just give you a little bit of information on this, and we can talk a little bit about how they're all formed. So the IP address structure, and we're going to talk about IPv4. IPv6 is a much larger address. It is in use on the public internet, but IPv4 is by far much more common in this particular day and age. So an IPv4 address is 32 bits grouped into four 8-bit octets. So 192.168.10.45 is an address, or 8.8.8.8 is another address. Every device on the internet will have an IP address. And you could take those numbers and convert them over to their binary string. So 192 is 11000000 dot, and then 168 is 101010000, so on and so forth. So IP addresses are stored as a 32-bit integer, 32-bit unsigned integer in the computer. And so being able to convert between binary and decimal is really important to really understanding IP addresses. So part of an IP address, and this slide doesn't really have it, but I believe it's the next slide will have it. In fact, I'll go to that really quick. But part of an IP address and kind of how it's assigned, it has a subnet mask. And now the subnet is defining the size of the network that that host can talk to. This is a little confusing, and usually I have a whiteboard and I draw it out and we talk quite a bit about it, but I don't have a whiteboard right at the moment. But what this means is that if you have an address, let's just say 192.168.0.42. Okay, that is the address for my particular computer. Now, I will have a subnet of, and we're looking at the third row here, 255.255.255.0. This means that my address, 192.168.0.42, can talk to any other address, which is 192.168.0.0 to 192.168.0.255. So, and again, it's a little weird thinking about this at the moment, but with the subnet mask, that defines the range of addresses you can actually talk to. So with the subnet, when you have 255, that means that that number cannot change. And so the subnet goes with the IP address itself. So 192 has that subnet of 255 there. That means that 192 can't change. 168 has a subnet of 255. That can't change. 0 has a subnet of 255. That can't change. But then the last number, which 42 in this case, that can change. And since that's a 0, that means it can be anything between 0 all the way up to 255 by changing all the bits one at a time. And there's 8 bits there, so you can get 0 to 255. So this is how at a network level, your device can talk to other devices without having to go through the router and talk through the routing protocols. So a question might be, okay, well, what if I want to talk to devices which are outside of that particular range? Well, in that case, what happens is your computer looks, and let's just say my address is 192.168.0.42 with a subnet mask of 255.255.255.0, and I want to talk to 8.8.8.8. Well, the first number, 8, isn't inside of 192, and I can't change 192. So in order for me to talk to that, I have to send the data from my computer to the router on my network, and then the router on my network will decide how it can get to 8.8.8.8. And that's known as routing, and that it's a whole week-long topic just talking about routing. So if you want to know more, look up how routing works on the internet, and you will find tons of information about that. So there are other subnet masks, and you'll also notice that to the left of this this third column, there's that /24. That's known as CIDR, or classless interdomain routing. It is just a way of representing 255.255.255.0 as a number. And literally, if you kind of look at this and convert the subnet mask over to a binary stream of numbers, or a bit stream, well, 255 is going to be 8 ones, 255 is going to be 8 ones, and 255 is going to be 8 ones, and then you have 0. So if you just count up the number of ones, you get 24 ones. Hence why you get /24. It says 254 usable hosts. It's actually kind of wrong. You have 253 usable hosts. There are 2 reserved addresses, but we'll talk about those a little bit later. Typically what you would have is between .1 and .254 is the usable host ranges. You'll notice that there is a /8 up there, which is a 255.0.0.0. That's 16.7 million hosts. That is used in large enterprise networks. There's also a /16, which is 255.255.0.0. That has 65,534 usable hosts. Again, that's slightly off, but close enough. At the bottom, you'll have a /30, which is 255.255.255.252. So notice that this is slightly different. You can only have 2 usable hosts in there. And this is one of the smaller, or this is actually the smallest usable network range in there. And so that 252, if you were to convert that over to binary, that would end up being 111111 00. That's 8, yeah. So those last 2 bits are the only things that can change. So it gives you 4 total addresses, but again, you need to reserve 2 of them because we'll talk about that in a little bit. So that gives you 2 usable addresses. So going back, the network versus host portion, the subnet mask determines the split of the particular network. So any bits which are set to 1 is part of the network, and any bits set to 0 is part of the host. And then you change the mask, which changes which devices are considered local versus remote. And when I say remote, that means that you just have to talk to the router to get it directed to the particular network segment. There's a couple of special addresses, and this is just useful to know about. 0.0.0.0, it commonly comes up in the default route. 127.0.0.1 is known as a loopback address. That's every device has that on there. That just means talking to itself. 255.255.255.255 is the broadcast address. And in fact, in a network segment, so I mentioned that my address is 192.168.0.42 with that subnet mask of a /24. The highest possible address in that network range is 192.168.0.255. That's the broadcast address for that network range. Hence why you can't use it in a normal assignment, because it's reserved for broadcast. 255, 255, 255, 255 is just a global broadcast to every device, even those outside of our network range. There's also 169.254, which is your link local. Commonly, you'll see this on a Windows computer when the network isn't functioning or the network cable isn't plugged in correctly or anything, or something of that nature. So understanding the difference between an IP address, which is the address for a device, the phone number, if you will, and the subnet mask, which is that goes along with the IP address and defines what computers it can directly talk to, is important to know how that all works together. So subnetting, and this is binary math. And again, if you have questions or you want a refresher, I do have a worksheet that I can send to you. Just let me know, and I'm more than happy to email that to you. But your network address is a result of the IP address and ANDed with the mask, subnet mask, and all the host bits are set to 0, and that will identify the subnet itself. And then the broadcast address will be the IP address ORed with the naught of the mask, and that would be the highest value of that particular network. And then the usable host range is going to be that network address +1 and the broadcast address -1. Hence why I said that the other slide was slightly wrong. I need to go back and fix it. So the total usable is 2 to the number of host bits -2 because of network and broadcast address. So some practical calculation examples. So if you have the network address of 192.168.10.0/24, which again /24 corresponds to a subnet mask of 255.255.255.0. Well, your network, or the first address, and this is not assignable, but is 192.168.10.0. And your broadcast is the highest value in there, which is 192.168.10.255. And thus your usable range is 192.168.10.1 to 192.168.10.254. So you can have 254 usable total hosts in there. Oh, sorry. Yes, 254 is correct. I was getting confused. So 0 to 255 is 256 total. So that would be 254 total hosts. Looking at 10.0.0.0/26, notice that 26, even though the number is bigger, is actually going to be a smaller network. And so the network is 10.0.0.0. The broadcast, which is the highest value in there, is 10.0.0.63. And then the usable range is 10.0.0.1 to 10.0.0.62 for a total of 62 possible addresses that you can assign in that network. And then finally, 172.16.5.4/28 has between the network is .5.0, the broadcast is .5.15, which gives you 14 total addresses that you can actually assign. So there are calculators out online that you can easily find. Just do a Google search for a subnet calculator. The first link is usually pretty useful. You could just punch in an address, punch in a subnet mask, and that will give you all the ranges and everything that you can actually assign to a device inside of that particular range. So why is it important in digital forensics? Firewall and IDS, intrusion detection systems, those logs will contain source and destination addresses. Knowing the subnet lets you know which segment it's going to talk to or where it needs to go. You can identify lateral movement across a network. You can attribute traffic to specific departments or Internet of Things zones. Penetration testing, network reconnaissance. This will be important because when you're scanning a range of IP addresses, you'll need to know what you can and cannot scan, what is available for you to talk to from that particular range and what is not. Same with evidence triage and scope definition. It's just important for all of that. And so knowing the network boundaries and knowing how all of this works is key for understanding all of it. So key takeaways, and I'm realizing that I'm missing a slide on this. There are 3 specific network ranges, which are known as private IP address ranges. There's 10.0.0.0/8, which is a private IP address range and typically used on enterprise networks. There's a 192.168.0.0/16, which that is commonly used on home networks and networks which are smaller in size. So home networks typically will use 192.168.0.0/24 or 192.168.1.0/24 because that gives you 254 addresses that you can play around with. And then there's 172.16.0.0/20, I believe. I'll have to double check and see. but that's a slightly bigger range. It's used on some corporate networks. It's used for some other things, but those three ranges, those are known as the private IP address ranges, and those are only used internally on a network. You'll never see them on the public internet. In fact, they aren't routable on the public internet. So when you're looking at a system, if you're looking at the internal network ranges, it's going to typically be in one of those three ranges. And again, enterprise networks, typically it's going to be the 10.0.0.0/8 range, or it might have a different subnet in there, but it'll begin with 10. So IP addresses, and again, these are IPv4 addresses. They're 32-bit identifiers split into network and host portions by the subnet mask. CIDR notation is that slash prefix versus the older 255.255.255.0 identification. And with that, you can calculate network, broadcast, usable host addresses. If there's a misconfiguration that will lead to communication issues, you want to verify subnet boundaries, and so on and so forth.